Hello students, in this video let us discuss one previous question that is from the September 3rd second session. Okay, so it is this question based on the elimination reaction. Okay, so very interesting question this is. So this one is the major product in the following reaction. Okay, this is the alkyl iodide here given like this tertiary butyl alcohol heating. Okay, so here heating almost favors elimination reaction. So option D is not possible in this reaction. Okay, so it is elimination reaction. So here heating symbol is mentioned. So it is 100% elimination reaction. But we have to decide which is a either it is a E1 reaction or E2 reaction. In E1 reaction, carbocation is the reaction intermediate. E1 reaction is a two-step process that involves first formation of the carbocation and removal of the proton. In a E2 reaction, that is a single step process, removal of the proton and leaving of the halogen simultaneously takes place. Okay. In a E1 reaction, the carbocation is the reaction intermediate, so that carbocation can rearrange to further more stable cation. Okay. In E2 reaction, there are no reaction intermediates we can see. So here no rearrangement is possible in E2 reaction. Directly elimination products are possible. Okay. So here generally in E1 reactions are favored by the weak bases and E2 reactions are favored by the strong bases. Okay. So here generally alcohols are the weaker acids as well as weak bases and their conjugate base like RO minus, here ROH is the acid, let us say here in this case RO minus is the conjugate base. Alcohols are the weaker acids as well as the weaker bases, but here conjugate base is a strong base. Okay, so that RO minus strong base favors a E2 reaction and this one favors a E1 reaction. Okay, now here in this reaction, so actually here the tertiary butyl alcohol is given. Okay, tertiary butyl alcohol is given. So this tertiary butyl alcohol generally favors uh, E1 reaction. Okay, because tertiary butyl alcohol is a weaker base. So here in this case, in a E1 reaction, the first step is ionization of alkyl halide. So first here ionization of alkyl halide, the formation of the carbocation, here secondary carbocation. So there is a chance for the rearrangement. So by H minus migration, okay, here H minus migration, so you'll get the tertiary carbocation. This tertiary carbocation is more stable, okay, than the secondary carbocation. Here in this case here 3 and here 1, 4 alpha hydrogens are there, okay. But here in this case here 3, here 2, here 1, so 6 alpha hydrogens are there, okay. So it is a more stable carbocation. It is a more stable carbocation. Now here in this case, the next step is the removal of the proton. So here proton can be removed from this one or proton can be removed from this one. Okay, or proton can be removed from this one. That means here there are three possible alkenes. So here in this case like this double bond, this one product, and next this is also one product, removal of the hydrogen from this one, and next one removal of the hydrogen from this carbon. This is the product. But here in this case, this is the major product because that alkene is thermally more stable. Here 3, here 3, here 3, here 2. So totally here in this case, the 11 alpha hydrogens are there. So this alkene is a majorly formed. Okay. So option is A. So actually here we can think about it is a bulky base. Okay. It is a bulky base. So here it produces a Hoffmann product. Okay. It produces a Hoffmann product. But here this reaction proceeds through the E1 reaction, E1 mechanism. In E1 mechanism, in at any chance, okay, there are no formation of the Hoffmann product. Always Saytzaff products are major in E1 reaction. Okay. So here in this case, for suppose the same reactant on reaction with potassium tertiary butoxide. Potassium tertiary butoxide. This is a very strong base. This reaction favors E2 reaction. This reagent, this base favors the E2 reaction. Okay. So a generally bulky base in E2 reaction favors the Hoffmann product. That means here in this case without any rearrangement direct elimination takes place. This is a major product. Okay, if you take potassium tertiary butoxide because that is a strong base and bulky base, generally strong base favors the E2 reaction. In E2 reaction, bulky base produce the Hoffmann product as a major product. Okay, Hoffmann product means here the less stable alkene, the alkene which has a less number of alpha hydrogen, that is a Hoffmann product. Okay, for suppose for the same substrate, if you use C2H5ONA, okay, C2H5ONA, here sodium ethoxide, so it is also strong base. Okay, it is also strong base. Now here, this strong base favors the E2 reaction. Sodium ethoxide heating, so it is a E2 reaction. Now in this E2 reaction, Saytzaff product is formed because the base is a smaller base. Okay, the base is a smaller base. This smaller base can remove the proton from the sterically hindered carbon. But here in this case, this is a potassium tertiary beta oxide. This potassium tertiary beta oxide means here that CH3 here, CH3 OK. Here, this is the bulky base. That bulky base cannot remove the proton from the sterically hindered carbon. So that's why here this base simply remove this proton. So as a result of this one, we will get this product as a major. Okay. Now here using sodium ethoxide. Okay. So this reaction again follows the E2 mechanism, strong base. But in this case, this base is a smaller base, so that favors a Saytzaff product. So that can remove the proton from the sterically hindered carbon. So product in this case is this one. Okay. That is. So here in this case, finally, we can see three types of products. Okay. So tertiary butyl alcohol, E1 reaction. In E1 reaction, first ionization. If there is a chance for the carbocation rearrangement, so rearrangement takes place by the H minus migration, we'll get the tertiary carbocation. So removal of the proton from this one, we'll get the more stable alkene. Okay. Here potassium tertiary beta oxide, it is a strong base and bulky base. Okay, strong base favors E2 and bulky base favors the Hoffmann product. The sodium ethoxide, this is a strong base favors the E2 reaction, but it is a smaller size base, so that remove the proton from the sterically hindered carbon to produce a more stable alkene. Okay, so compared to this alkene is the more stable. Here 3 alpha hydrogens, here 3, here 1, totally 7 alpha hydrogens. By the hyperconjugation, it is a more stable one. Okay, so here three are the different conditions, so we will get the different products. Okay, that is the one previous question, September JEE main. Okay, thank you for watching. Please subscribe my channel.